Good morning, all. I'm Giulia Terrosi, and I'm here to present you my dissertation work, Guidelines for BIM Information Management at Design Stage. Nowadays, many companies are using BIM tools, and even if they are proficient in that use, they face a lack of information management. It has been proven that an organized process of information increases design productivity. To achieve this benefit, it is necessary to have a BIM implementation inside the company. Information management is the focus point of BIM processes, and to implement it, it is necessary to follow guidelines. This issue was faced also by BIMS, the partner of this dissertation. BIMS, in fact, is really proficient in using BIM tools, but needs an organized process for information to apply to the process lifecycle. To obtain a more specific analysis of the process was divided in two parts, the design stage, which I took care of, and the construction and operation stage treated by a colleague. During the research phase, the major problematics were found about roles and responsibilities. In fact, each country and company have their proper naming, and some of them overlapping in definition or competencies. Regarding the process workflow instead, it is hard to find one which clarifies the relationships between the actors involved and that could be adapted to different projects. Moreover, according to some authors, it is hard to find a proper definition of document due to the lack of knowledge around them. Due to companies' lack of information management, the main objective of this dissertation was to create guidelines for it. To accomplish this objective, it was necessary to divide it in sub-objectives according to the problems found. It was in fact necessary to divide it to identify roles and responsibilities and unify them under unique definitions, develop a comprehensive workflow adaptable to country regulation, develop specific tools to support companies and BIM managers during the design stage, and develop documents template to be adapted to different standards. The dissertation methodology was gathering the best practices from the literature review, then develop output and validate them. As this work addresses several problematics and the idea was to create guidelines, it was decided to develop it with a handbook structure. In fact, to each chapter correspond a part of literature review and one with an output, as it's possible for this image. The outputs of the dissertation are two matrices regarding roles and responsibilities, a workflow for the design stage, an EIR and a BEP template, and a CD platform comparison matrix. So, starting for the first output of this work, it is a table created to clarify, unify, summarize roles definition and their responsibilities and expectable competencies. The table collects traditional roles as per architect, engineer, project manager, and the new roles introduced with BIM Advent and collected under three main categories: BIM manager, BIM coordinator, and BIM modeler. Those roles here are divided to have an accurate definition, which is useful to quickly identify the most suitable role for a project. The second output is a matrix to evaluate team members' competencies. The matrix is divided in three parts. The first one, where team members and their roles are listed. Here, traditional and BIM roles overlap. The second part is a weight rate section subdivided in three competencies areas: production, management, and strategic. The third part is auto-filled once the roles are selected. The BIM manager is responsible for the final evaluation, and this matrix may be used to hire an employee or after training in the company or for annual track of the team member. The third output is the workflow for the design stage. It is based on IPD methodology, and it has a color schema to identify discipline and stakeholders. The workflow is divided in strategic definition, preparation and brief, and design, which is again divided in concept design, spatial coordination, modeling and coordination, automatic licensing, detail, and design for construction. The workflow structure consists in four main roles: stages, explained before, stakeholders containing information responsible and responsible, activities that should be validated and approved, deliverables containing documents, model, and it is all inside the common data environment. And it was also established an arrows hierarchy according to the associations. Now I'm going to present some of the stages and some main features of the workflow. The previous introduced matrices are used to select the team members. The stakeholders work together in working groups, setting their requirements for the project, and the BIM manager coordinates and supervises the working group to collect requirements to compile the EIR and the BEP. In the phase of modeling and coordination, is noticeable the relationship between coordinators and their related discipline teams and the deliverables to produce. Please also notice the color schema that links the disciplines and the stakeholders, and the contribution of the supplier that provides certified objects for the models. Those components are stored in the library object inside the CDE. The BIM manager again coordinates the teams and validates their work. In the last substage of design, the facility manager and the contractors work on discipline models inside the federated one to produce shop drawing for the construction, and the BIM manager coordinates and supervises the work. Now I will present the first template developed for the dissertation. It is based on a comparison between 4 standards, the American, the British, the international one, and the Italian one. It was decided to follow the ISO standard as this collects the appointing and appointed parties requirement. For this reason, it is called a change and not employer information requirement. The template is divided in 5 sections and to respect the color scheme of the workflow. It is also developed in Excel to be modified and adapted to different projects and standards and digitally signed. The first section of the template contains the general information of the project and the stakeholder context. The second one, the applicable standard for the project that could be mandatory or optional. The third one, the technical information section, which contains the required model exchange formats for communication, drawings, model, or other, and the chosen CDE platform and explanation of its core structure, the project coordinates, and the general required LOD. The other sections contain a table to define roles and responsibilities and introduces the BEP ratio matrix, the data segregation of the model for each stage, the data security establishing stakeholder access to the CDEs folders, and the last section instead is dedicated to the plan of work, establishing the main milestones and deliverables. The second template developed was the BEP1, and as per the EIR, it is based on the comparison of the aforementioned standard. And also for the BEP was chosen the ISO standard, which proposes a unique document to be updated after the contract. It is divided in 8 sections and respects the color scheme of the workflow. Also, this template is in Excel to be tailored, adapted to different standards and digitally signed. The first 2 sections of the template contain the organogram, which represent the structure of the main stakeholder relationships, and the BIM coordination that represent graphically the hierarchy inside the discipline teams and where the deliverables should be placed inside the CDE. The subsequent section contains the ratio matrix, and the software section instead contains the list of the software used for the project, the version, and how often it should be updated, the scope of using the software, and for which discipline. The other sections contains the naming convention, the library object parameters, the level of development where it is not assigned a standardized LOD for each stage, but a specific LOD is assigned to each object according to the information needed in that stage. And the last section is dedicated to the project milestones, where are established milestones, deliverables, meetings, and workshops. The last developed tool is a CDE platform comparison analysis matrix that aims to support companies in evaluating platforms according to project needs. For this reason, the first row is dedicated to the BIM manager, which sets scores for the selected criteria according to the importance for that project scope. A color gradient is established to help an easy identification of the most suitable platform for the project. White cell is for the less suitable, and the dark blue is for the most suitable one. In case of a tie, the project column could be used as an additional criteria. The work was validated in 3 moments along the dissertation work with the partner BIMs. The first moment was a meeting with the 2 of the company partners and the 2 project coordinators. A case of study was introduced and technical questions were made. The second validation was an in-depth interview with BIM's related issues and processes with the technical coordinator and BIM's partner. The third validation instead was done presenting the work to a panel composed by the 3 partners of BIMs and the 2 project coordination. The work was approved and validated by BIMs. This validation was important on a professional point of view to apply the work lately in the market, of course. In conclusion, let me sum up the main points of the work. An organized information management will produce an efficient information delivery, reducing waste of time and resources of the companies. The presented guide, enriched by the documents created, could be useful to implement BIM adoption along the design stage. Regarding the developed work, the competencies matrix helps to select roles and define their duties. The maturity level matrix supports team member evaluation. The workflow clarifies stakeholders' action and deliverables. The EIR and BEP could be tailored for different project location and standards. And the CDE comparison matrix aims to assist the CDE platform choice. For future development of this dissertation were pointed out the possibility to explore more each stages of the developed workflow, enrich the EIR developing an OIR, AIR and PIR templates, enrich the BEP developing MIDP and TIDP templates, create a KPI and a matrix to track project processes in time, and a study on the handover between the design and the construction stages with the development of parameters to track the full coordination. From what I know, this year, another dissertation was made about this topic, and I can't wait to read it, of course. And that's bringing me to the end of my presentation. I would like to thank you for your attention.